What are aggregates in domain-driven design? Have you ever wondered how to keep your business rules safe and then multiple objects work together? In this video, we will learn what aggregates are in domain-driven design, why they are important, and we will use a simple online shopping example to make everything crystal clear. Let's get started. What is an aggregate? An aggregate is a group of related objects that should be treated as a single unit. Think of it as a boundary around objects that needs to stay consistent together. Inside an aggregate, there can be entity, value objects, and one special entity called the aggregate root. The aggregate root controls access to everything inside the aggregate. Simple real-life example. Imagine you are placing an order on an e-commerce website. An order contains order information, order items, shipping address. Visually, it looks like this. Order item, shipping address. In domain-driven design, all of these can form a single aggregate. The order becomes the aggregate root. Why do we need an aggregate? Let's say an order should never have a negative quantity. Without an aggregate, someone could directly modify an ordered item and accidentally break the business rule. For example, quantity -5. That doesn't make sense. Instead, all changes must go through the order aggregate root. For example, add item, remove item, change quantity. The order validates the rules before making changes. This keeps the data consistent. Aggregate root. The aggregate root is an entry point to the aggregate. External code should only interact with the aggregate root. For example, order.add item with parameters product ID and quantity. But this is not allowed. Order item dot quantity equal to -5. The aggregate root protects the internal objects and ensure business rules are followed. Example in C#. Let's look at the simple example. Here, if the quantity is lesser than or equal to 0, then it will throw an exception. Notice that order item is added only through the order. The order controls the business rules. That's exactly what an aggregate root does. Another easy example, bank account. Imagine a bank account. A bank account contains account information, transactions, balance. The bank account becomes the aggregate root. Instead of doing balance equal to balance -100, we do withdraw 100 or deposit 100. The bank account validates whether the withdrawal is allowed and keeps everything consistent. Aggregate boundary. An aggregate defines a boundary. Everything inside the boundary must remain consistent. For example, order aggregate, customer aggregate. These are separate aggregates. An order should not directly modify a customer. Instead, it stores only the customer ID. This keeps aggregates small and manageable. Common beginner mistake. Many developers create huge aggregates. Inside the customer, orders, payments, reviews, notifications, addresses. This becomes difficult to maintain and can hurt performance. A better approach is customer aggregate, order aggregate, payment aggregate, review aggregate. Each aggregate has a clear responsibility. How to identify an aggregate? Ask yourself 3 questions. Which objects must stay consistent together? Which business rules must always be protected? Which objects should be updated in a single transaction? The answers usually reveal your aggregate boundaries. Conclusion. Let's quickly recap. An aggregate is a group of related objects treated as a single unit. An aggregate root is a main entry point that controls access. Aggregates protect business rules and maintain consistency. In our example, order is the aggregate root, order item and shipping address belong to the order aggregate. All changes happens through the order. That's the key idea behind in domain-driven design. Thanks for watching and happy coding.